First of all, warm welcome, Dinesh,
Thank you so
and
much.
many congratulations on the success of Agnikul. I was just doing a research and I have realized there are so many things happened first time through Agnikul. So just read few of them. First, semi-cryo engine from a private launch pad. First launch from India using Ethernet-based architecture to connect flight computers.
Yeah.
So how this idea evolved of Agnikul, if you can just share some starting comments, how Agnikul formed and what was the idea behind it?
So basically, everybody loves space, right? And everybody loves rocket. So we started our journey in like making launch vehicles, and in a something different way, like different way in the sense like to make it more affordable. And launch vehicles are like there have been a standard template on how it has been done so far, and we wanted to explore those options and make the launch more affordable and make it launch anywhere, anytime, affordably. So that is how Agnikul started.
Yeah, I completely agree because space tech is something which everyone aspire to and be part of it. But I have visited Agnikul
Okay.
and I visited your facility. What I have realized is when I was meeting few of your colleagues, seniors, it's a very young organization. So how you see, how you got these people into space, and as we were discussing, the average age is 23 to 28.
Yeah.
So how you got these young brains into Agnikul, and just a connecting point on this, how this achievement looks like, because I know we talk about the success, but how you see and what are the challenges you have seen to come and got this success?
Okay. So one of the main thing that really helped us is like having a young team, because with young team, lot of creative ideas came. So with that, we were able to explore a lot. So that is one of the major driving factor, and we found lot of people who are like very passionate about space and rocket science. So uh, it's really the people and the passion behind them really took us to where we are right now. And this particular suborbital launch happened because of all the young people uh, who were like spent their full time basically like 24/7. We were there for like almost an year with a lot of test experiments, and with that, this launch was able to be possible in the first attempt itself.
No, and absolutely. And what, if I ask you, what is that secret sauce of that success? And how you guys have enjoyed that and how you have seen that success? What's mean for you?
It is obviously the team bonding. So we had a very like large team who was working in this particular mission at least, right? And we faced a lot of challenges right from the day one. It has not been an easy journey in making a rocket science. We faced like thousands of failed experiments, and like it's like 100 bad days and one good day. So we had to go through all the journey together as a team and keep our morale high, right? And with the young team, basically, we take more responsibilities. Like people take more responsibilities if they have passion. They take it like with utmost care, and they try to be on top of the thing, right? So that is what made every individual to be on top of the thing what they were doing. And as a team, like we kept our morale high, even in all the failures that we were having. Even in the launch attempt, we had like a few call offs that happened. 4 call offs happened. So during that time also we stick together, because there was one call off, and immediately the next day we attempted. So already there have been like 3 or 4 sleepless night. Then it was like one more night, like we again spent, did some testing, had to debug something, do some meetings, then came back ready for the next attempt. So this is how it has happened, and we are so proud that that is a amount of energy and the effort that it took us to make the launch successfully happen in the first attempt.
No, it's absolutely what we have seen, what we have learned. It's absolutely fantastic. And if I ask you in a very layman language, because the way I've started, first semi-cryo engine,
Yeah.
what does it mean? Because semi-cryo engine, and I know there was a 3D printed
Yeah.
engine. So if you can explain how important this is and what is the role it played in the complete launch?
Yeah. So this has been quite a journey of making this single piece semi-cryogenic 3D printed engine. So when we started our engine development from scratch. So we decided we'll go for semi-cryogenic technology because it is much more affordable and competitive compared to other propellants, right? And it is safer to handle as well. So we decided that from there we started developing our engine. So conventionally, if one has to make a rocket engine, it takes about 6 months to make just one engine. So we took those inputs from the field. We did a lot of surveys and other things. So we adapted our manufacturing technology to be additive manufacturing. So from there we started making our parts in additive. We just started with making small parts, then try to integrate as much as possible. Then finally we come up with a design that was like single piece. So the entire thrust chamber is like one single shot, and we could able to do in just 3 days. So the complete manufacturing time of one engine is like less than a week time. So you can compare like from 3 months to a week, it's a significant improvement. So the launch frequency that is possible today is like 20, 30 launches per year. That has been the industry right now, except SpaceX, where they've been reusing their rockets. If we can make the rocket engine on other parts manufacturing time much faster, just like how automobiles are doing, I mean, not in that scale, but at least a fraction of it, we can launch like hundreds of rocket in a year. So that is our major goal. So we wanted to launch one rocket per week. So that is our ultimate goal. So right from every nut and bolt all the way to engine, like we kept that in mind, made sure like use the modern technology that is available, because we are so lucky that we are in 21st century. The industry has developed a lot. Like we have so much modern technology in manufacturing as well as simulation, design, everything. Back in 70s and 80s, where the current generation rockets are like designed, that much technology was not available. So we are so lucky that we have so much technology around, and we wanted to make sure we use the modern technology to make rockets. So it's like 21st century rockets, right? That's what I would say. So we use that technology and make sure we can get the most affordable rocket, technologically advanced product, and that can be made in a much faster way that has been never seen before. That is the major idea.
Fantastic. It gives me goosebumps hearing all those stories. If you have to relive the same moment,
Yeah.
what do you see the significant challenges what you all have gone through? If you can highlight two or three.
Yeah, so this particular launch, like we have been in Sriharikota for almost like 8 months. Last 8 months fully we were there. So we had to go through a lot of testings because our vehicle have been completely tested in and out in Chennai in our facility. Then we assembled our rocket and taken it to Sriharikota. So there, switching to that condition because it is close to coast. You might have seen from the video, our launch pad is like exactly located on the coast. So we had to face those environmental challenges as well. And the rocket has been tested again, like in Sriharikota. So basically, there we have to work in parallel with ISRO's STSC Sriharikota team. So that was a quite challenge because we worked in a place like it's our team.
Yeah.
Now we have to work with ISRO where they're launching orbital rockets, like multiple rockets in a year. So we have to talk to a lot of elite people there and work with them and work in a sync with them, right? Match the timing and all those things we had to do there. So that was quite challenging. And after all the rehearsals and everything, we went for the first launch. And we had few problems. I mean, some glitches in the system, and our onboard system, onboard software detected that, and it called off. So it was like we went to that peak because I was also there in the mission control room. So when the countdown ticks, right, T minus 10 minutes, T minus 5 minutes, the moment the ALS starts, we are like, once the ALS starts, there is no human intervention. We don't do anything. We just start the ALS, then wait and see, right? The 2 minutes of just, we can only watch because the system does everything. So that moment we started the ALS and watching the systems, right? It was like we went to that peak. Then immediately there was a hole. It was like suddenly we don't know what is happening, right? There was like sudden freeze happened. So that was like completely different experience that we have never seen before. And then finding the issue, debugging it, and coming back again in a very short time, that took us a lot of energy. And without the team's passion, it wouldn't be possible. And we had like 3 or 4 of call-offs happen, and lot of testing went in the background that we have not obviously told many places. A lot of testing, sleepless nights, again debugging, changing things. A lot of things happen in the background. And finally, in 28th of May, we attempted one. I think that was telecasted publicly. I think 28th of May. There also we had call off just I think 11 seconds before the
Okay.
T0. So it was T minus 11 seconds we had a call off. Engine was about to start. That was like, we were like, okay, engine is going to start. It was in the last second, so it wasn't call off. It was like, oh, okay. What is happening? So that was like completely new experience. And then we found the issue within a day, we fixed it. And then 30th, 20th, 29th night, we started the countdown. 30th morning, everything, I think that day, everything went as per plan. So some of us were sick, like even I was also sick that time. But we came back, like took pills, came back and sat there. We wanted to somehow make this launch happen, right? So that happened, and that liftoff was something I don't have any words to explain. So
No, I can see on your face the energy and passion.
yeah.
This is something. But moving on from here, so what are the plan of Agnikul in next 5 years? How you see we have done this successfully? So what are the future plans?
So after the successful launch of our suborbital mission, so we have lot of learnings from that. So basically, our suborbital rocket had as complexity as the orbital vehicle. It has an onboard autopilot system. It's a self-control vehicle, and the engine had gimbal system. It's a semi-cryogenic engine. All the flight computer, avionics system, everything is same as the architecture, and the hardware is same as the orbital vehicle. So we have to take those learnings, make a larger vehicle, that is our orbital vehicle. So our target is to have one orbital launch next year, that is 2025. Then from there, increase the launches like 2, 4, like that in every successive years. So that is our major goal, right? And we wanted to make the system completely foolproof, right? So we wanted to make the system more rugged for rapid launches. That is the major idea. Not just simply launch, but also make the launch vehicle much more rugged, and improve the launch vehicle's ability to have a rapid launches possible. Not only the launch vehicle as well as the launch pad also. The ground system has to be capable enough to do that as well. So because the launch pad also it is ours, we have the full control of optimizing the vehicle as well as the launch pad to make rapid launches possible.
And in the current scenario, if I just go back 5 years or 10 years back, India is doing a lot of stuff in space tech. So how you see role of Agnikul not only in India but in the global space tech arena? How you see that, and what impact or disruption, rather, I would say, Agnikul can create?
Yeah, so single piece semi-cryogenic engine is one of the disruptive technology that we have done. Like it has never been flown fully 3D printed as a one shot. There is no engine that flew a rocket. So ours was the first, right? I can proudly say. And similarly, the Ethernet-based communication system for our packages, the avionics system, and the software also was completely in-house. So we are trying to innovate every single system that is possible, right, and make it more rugged and affordable. So that itself is a major, it's a complete change, right, in the way in which we think how launch vehicle happens, because till date it is like we have a launch vehicle, we can launch. If the satellite comes, we can launch. For example, if my payload capacity is 1 tons, I can take a satellite of 990 kg, and if there's any small CubeSats that are available, I can piggyback and launch it. That has been the mindset so far. But what we are trying to do is have a modular launch concept. So our first stage is having 7 engines, and so our payload capacity is dynamic. So from 100 kg to 300 kg, we can launch any satellites. So if a satellite of 100 kg comes, we don't need all 7 engines. We can only go with 5 engines or 6 engines. So bring the launch cost also. That is something like tailoring the rocket for the payload that is there and doing an on-demand launch. So that itself is a new idea that has never done so far. So we are trying to push the space industry to something more like a cab concept, right, in there. So that will be like a complete game changer. Like we can tailor our rocket so that we don't have to make the customers wait for launching the satellites. If it's a 30 kg satellite, yes, we can launch it with a small, I mean, the same vehicle with less number of engines and cheaper vehicle. If the satellite is like 150, 200 kg, we can tailor the rocket accordingly. So this is something we can do. The launch vehicle is still the same. We are not making new rockets every time. It's just we are configuring the engines, batteries, and all those things to uh, make it more competitive. Right? That is something like it's a new kind of idea itself that we are doing in the global market.
And in customizing the space, I can't even think about it based on the payload, but a
Yeah.
very interesting concept. And I think being an Indian, it's already in our DNA how to save the cost.
Yeah.
That's how it starts. And coming back to the question which I've started with, You talked about the averages is 23 to 28. How you have leveraged the complete young minds in Agnikul? There will be, I'm sure, lows, highs, distractions. So how you have leveraged coming everyone together and working in a completely startup kind of model like Agnikul? How you have seen that? Anything which you want to highlight uh, about the young workforce in Agnikul?
Yeah, we have lot of key people. All of them are like 20s of age, right? And all are passion driven people.
If you don't mind, what's your age?
27.
Okay.
So all are passion driven people. So it's not like college like they're forced to do or like we are forced to do, right? We take responsibilities. Like we have a lot of bigger things like big engineering tasks, right? Big core engineering hardware. It's a rocket science. So when we feel that responsibility, because I've been in the company for past 6 years, so 23, 24 age, that time I was working in injector, which is like heart of an engine. So it's a quite huge responsibility. I was developing an injector for the rocket engine. So that kind of responsibility when we face, our mindset itself completely changes. So how we were in college or school, that idea itself changed, and suddenly we feel like more responsible. And with the passion that we had, it drives us completely, and we go crazily, right? And also with the help of our advisors, who are retired ISRO people, they used to tell a lot of stories of how their journey was, like how their 30 years of journey has been there in ISRO, and it used to like motivate us further. Like they'll tell like we did this thing happened, like this kind of interesting story happened, we had to travel in a bullock cart, like that we used to hear stories, and we like, yeah, we have bikes, we can take it. So it's a merge of both the previous ideas and what they went through and the passion that we have, right? That really helped us. Once we feel the responsibility, we will do it. That's how I've seen every single individual in Agnikul. Once they felt the responsibility, you can see a complete change in how they were when they came to how they are here right now. It's a complete change.
Fantastic. And innovation also takes you to filing the patents because definitely you want to go with it. So, any patents filed in Agnikul on this particular process?
Yeah, we have granted two patents. So one is single piece, so design and manufacturing of single piece 3D printed rocket engine. We have a patent, and one more patent we have for the modular launch concept.
Okay. And how you are fostering the innovation culture? Because I know it's not right at my part if I talk about innovation, it's all innovation in Agnikul. But how you foster that innovation on a daily basis? Because sometimes it also gets very monotonous. So how you build that culture?
Yeah, so I think the concept our launch vehicle is like completely new. It's a different class of payload, right? And size is different. The even though the principle in which it works, like it's a electric pump driven engine, and this technology is like very new, and every single system that we have to develop from scratch. So every system we have to put our innovation. So it's not like the system is off the shelf, we can take and adapt, because those systems are very bulky and they are big. We can't just simply take and put it here. So we have to again re-engineer it, keep the principle same, re-engineer it, bring down the size, mass, then make it. So right from changing a fastener from one spec to other, even though it's a trivial change, it is a small innovation that we are trying to save some mass there, right? All the way to like making our own avionics module. So the packages that we have, the flight computer, engine computer, that was fully developed from scratch in-house. And we used 3D printing technology to make those packages as well, the outside shell structures. Like we have never seen that before, right? It's just an idea that clicks in one of us, and then we then sit together, brainstorm the idea what we can do, and then just go into it full. Like we have like proper discussion amongst the team. Once the decision is taken, then everybody just goes full on it, then gets it done.
The complete belief was there and
Yeah.
you turned it into a success. Uh, I have just a last question from you. Any message for young workforce people, those who are in college? Because many of them are aspiring to become, getting into space tech and innovation and things like that. But any message for you what they should do if they
Yeah.
want to be part of this?
I feel like basically it's passion driven more, and they need not be toppers. That's what I would say. Just the fundamentals is enough. And engineering is a very beautiful subject. Basically, it's more than books. It's more practical, and it's more documentation, I would say. So in colleges we learn more theory, but practically what is happening is the engineering. So once we see it, it's completely new, different world. Like what I have seen and studied in my college time, and what I have been doing all in my hand. Like I put my hands, dirtied my hands in making things work. That seeing in hardware is completely different ball game. So I want engineers to look into that part of world, not just see engineering as just a theory and just focus on getting marks. Marks are there, but uh, engineering is much behind it. It's much bigger thing, right? Which we are not seeing as a people here. So I want people to see engineering as a more practical way. In a day-to-day life, lot of engineering is happening. I want people to see those details, right, and pursue their interest in many different things, not only space. Talking about space, like we have completely new technology that is around the globe, right? So there are like lot of scope is there. Like people can like enjoy working here. It is tough. It is not that easy. You have to keep our heart in a very good condition, because it will be like 100 bad days and one good day. So it is not that easy, but with passion driven, I think it is possible for every people to succeed in space industry, not only in space, in every part of engineering.
And that's what people see, one day success, but as you rightly said, there are so many 100 days of failure. Or not say failure, but journey towards a success,
Yeah.
you need to have that patience and how you will take it further. But I really enjoyed, Dinesh, what
Yeah.
you guys are doing.
Thank you.
And many congratulations to Agnikul, and I'm sure we will see more success in the future. Thank you very much for talking to us.
Thank you so much. Thanks for inviting me.